All right, welcome back, everyone. So we're just finishing off this last tiny little section on side-by-side box plots. We just have the bottom of page 11, top of page 12, and then we are done exploring data. Not really, we'll actually be doing that throughout the semester, but we're done with this note packet. And so remember we were talking about this study that had teachers in this St. Louis school district in Michigan. Some of them had a bachelor's degree, some of them had a master's degree, and then we measured their base salaries to kind of compare. Saw that there's really not much of a difference between the two, which we thought was kind of odd, or at least I thought it was kind of odd. Because we would expect the master's degree teachers to maybe be paid more because they have a more advanced degree. And so let's go ahead and bring back concepts that we did from section 1 to maybe kind of reason through why there's not much difference between the two groups. And so take a moment to just think about, was this an observational study or an experiment? So I'll go ahead and give you a second just to pause the video to think about that. All right, so you'd want to go back and read about how the data was collected. It just says that we have salaries of 71 teachers. Some of them have masters, some of them have bachelors. It does not say that we randomly assigned some teachers to get their bachelor's degrees and we randomly assigned others to get their master's degrees. That would be an experiment and that would be nearly impossible. So this was just an observational study. All we did was observe the degree type that teachers had and their salaries. So because this is an observational study, that means that there could be possible confounding variables that aren't balanced out like they would be during random assignment of an experiment. So again, go ahead and pause the video real quick and think about a variable that could possibly be confounding. And remember that our definition of confounding was that it has to be associated with the explanatory, which in this case is degree type, and the response, which in this case is salary. All right, so there are many different variables you could have come up with. So just if the one you thought of isn't the one I'm about to write down, that doesn't mean it's unreasonable. But for the sake of kind of filling this out, the variable I thought of is age, and age of the teacher. And so then let me give my reasoning for this. So I'm going to say age, or I'll make this briefer. I'm going to say younger teachers could get paid less. And that's just because they have less experience. So your salary tends to grow the longer you're at an institution. And so it's associated with the response. And I'm also going to argue that younger teachers are more likely to have a master's degree. And so I'm thinking that that's the case because master's degrees have really become more popular recently. And so I think more often now, younger teachers are getting them, whereas 40 years ago, if you graduated, you usually wouldn't go ahead and get your master's in education. And so it's associated with the response, which is salary, and the explanatory, which is the type of degree. Again, this is just could be. We don't have data on age, so we can't actually check, but this is one kind of logical reason why these box plots turned out to be so similar. All right, and so this last little section is just going to kind of expound or explain further why we need to look at spread in addition to center. And so I'm going to draw kind of a little example as to why we need to do this when we're looking at association. And so I'm going to draw something like this. And maybe something like this. I'm going to call this A so that we know kind of which one's which. This is our group. This is our response. And for B, I'm going to use the same exact median. So we have the same exact measure of center, but I'm going to make the spread a lot bigger. So that should line up with that. This median line should line up with this. All right, so this is group 1, this is group 2, group 1, group 2. And so the medians for both of the group 1s are exactly the same. The medians for the group 2s are exactly the same if I drew them right, which I never do, but they should be. And so think for a second, in which of these graphs is there more evidence that the two groups are different? A or B? So in which graph is there more evidence that the group is associated with the response? All right, and so the kind of logical reasoning behind this is that in this graph, groups 1 and 2 look really different because there's just like no overlap in their spreads. Almost everyone in group 1 scores higher than almost everyone in group 2, meaning that group 1 tends to have a higher response than group 2 from this graph on the left. For the graph on the right, groups 1 and 2 look super similar. And that's just because there is a lot of overlap in the spreads. So now, even though the centers are exactly the same distance apart as they were in this first example, there's so much overlap that it's kind of hard to say that one group is doing much better than the other. And so that's why we kind of really need to look at spread when we're making this kind of judgment about whether one of the groups has a higher response than the other. We'll come back to this idea again when we do the formal statistical analysis for this type of data, and we'll kind of see where spread, how it comes up when we actually do that analysis. Okay, so as always, let me know if you have any questions, and I hope you all have a great morning or afternoon or evening or whatever time you're watching this video.